Tensors explained. What the fuck is a tensor? Like, if you started studying and if you started getting into artificial intelligence, and especially if you started using the library TensorFlow or even PyTorch made by Facebook, what you will soon realize is all of this TensorFlow is basically flow of tensors, and this tensor is getting transformed during the flow. But what the fuck is a tensor? Well, that is this video. I'm going to try to explain what is a tensor. It is kind of really simple, but sorry, but if you think really deep about it, it's kind of really complex. And the reason why this happens is tensor is basically a data structure, and the way the data is structured is using a simple concept. It is just the top layer structure is made by grouping the bottom layer structure, and this keeps happening over and over again. Like, it is a recursive repetition of a simple concept where the top structure is made up of bottom structure. Let me become really practical. So let's start with the simplest data structure, data. So data is the simplest data structure. And what is the data? Data is just number. So let's take me and let's take some data points about me. Like, what is my age? 31. That number is one data point. And anything and everything about me can be converted into a number. For example, let me take a really harsh data point. Very, very tough to digest. How many times have I been divorced? The data is one. Actually, not divorced, but separated. But you get the picture. Even emotions can be quantified and can be converted into a number. So if you are thinking like, what is my anger level rated from 1 to 10, then it is also a number 6, where an emotion is mathematically converted into a number. So like this, you can take infinite number of data points just about me. So let's start simple. Let's take n number of data points. So we take n kinds of details about me. Each detail is a number, and we arrange all these numbers in a kind of a list, like a straight line, analogically. So this list of or group of numbers is called an array in computer science. So in physics, we call this a vector, but let's not confuse ourselves. This is an array. It's just a group of numbers. Now this array is actually a data structure, and it's a simple data structure. It's just made up of data. Now, let's say in this flat, there are other people in this flat. So let's say I take data about them also. And so I took n data points about me, and similarly, the top floor neighbor, I take n data points about him. I take the bottom floor neighbor, I take 10 data points, n data points about him, so on and so forth. I take m people in this flat. Now, what has happened is I have created a data structure. This is nothing but a matrix or matrix. I don't know which one it is. We have created a matrix, and this data structure matrix is made up of arrays. So matrix is a data structure that is formed by grouping a smaller data structure like an array, while array is a data structure that is formed by grouping a smaller data structure, basically data, right? You can see that the pattern keeps on going. So we took n data points about me, and then we took m people in this flat. But we can also take LMNO, O flats in the street, right? So now what we are doing is each flat in the street is a matrix. I'm taking a bunch of matrix and I'm grouping them. And now what I have got is a cube. And the reason why this is a cube is analogically think of this matrix as a card, like playing cards. So each flat, the data, so each so each flat is basically a card of data. And when I group like 10 flats or LMNO, O flats in this street, I have got O number of cards. Basically, I've got a deck of cards, and a deck of cards is basically a cube. So basically what has happened geometrically what has happened is we take a point data number, we take lots and lots of points, we group them together and we get a line. straight line. The dimension has increased. Now it is one-dimensional line. Now take a bunch of lines, group them together, and what you get is a surface, basically a sheet, two dimensions, x-axis, y-axis. Now this sheet, take groups of sheets and combine them. What you have got is a cube, three dimension, because it's got x, y, and z, right? But in maths, we can only go till three dimensions, right? Like fourth dimension, fifth dimension. They do talk about it in physics, but I don't understand that much physics. But in reality, how that converts is basically I took me, data about me, then I took data about all the people in this flat, then I took data about many flats in the street, then I combined streets to form a city, then I combined cities to form a state, combined states to form countries, countries to planets to solar systems to galaxies. So you can keep on creating a new level of abstraction using lower levels of abstraction. So why am I talking in such a complicated fashion? Well, the reason is anytime you start collecting data about the world, it starts out really simple, but then very soon, very fast, it gets really, really complex. And arranging and collecting and organizing and structuring the data structure is what we are trying to do in this tensor. So geometrically, we saw that we are able to group from points to lines to surfaces to cubes. We are able to go from one dimension to two dimension to three dimension. But in mathematics, ideally, a tensor can go infinitely. How does this translate to real life? Well, we started from me, collecting data points about me. And then we kept zooming out, zooming out, zooming out when we went to galaxies. But we can also go the other way around. We can actually zoom in and we can say, I am a structure that is a grouping of substructure called cells. And then cell is a structure that is a grouping of smaller structure called atoms. I can dig into atoms. I can go into quantum physics. So you can see that the packaging goes both ways infinitely. Like according to the current technological advances, we are able to see some galaxies. I don't know what we are able to see actually. I am not up to date with the current science. And we are able to see that we have gone till quantum physics, quantum mechanics. But 100 years from now, when technology is even more advanced, we will see that it keeps on going infinitely. At least that is my prediction. Let's see. Let's call it Vignesh's law. But I'm just joking. But we can't keep naming planet, solar system, galaxy. We can't keep coming up with new names, right? So a simpler way is to just number them. Start somewhere as zero and then start numbering this as first dimension, second dimension, third dimension, and the other way as -1, -2, and -3. That's the only logical way we can go. So in our case, in artificial intelligence, when we are grouping and structuring data, we have come till arrays, matrices, and then we have come till a cube. Now, how do we go further from here? Well, how do you go further from here is the same logic. Just zoom out. Just take this cube, zoom out. Now, when it's very far, the cube looks like a point. You know where I'm going, right? If it looks like a point, then we have started again at the beginning. Now create. Now go for that. I have already done LMNOP some p dimensions. Now the qth dimension of this tensor will be grouping cubes. So take a list of cubes. Say I said n number of data points, right? Similarly, q number of cubes I have taken. So what is this list of cubes? It's an array. It's an array of cubes. Again, make the array into matrices. Take groups of arrays. A group of arrays, that will be a matrix. Take a group of matrices, that will be a cube. Zoom out the cube to look like a point. Now take a list of cubes. So the pattern just keeps repeating from point to array to matrix to cube. And the cube just becomes the point again. So cube array matrix, cube array matrix, cube array matrix. This is how we are packaging. So basically an analogy for this is take a gift Now gift wrap it with a red color gift box, RGB. Next gift box will be green in color. Next gift box will be blue in color. So I keep on packaging the gift inside a bigger gift. Keep packaging that gift into an even bigger gift. So, but I keep repeating the pattern. RGB, then after B, I again take a red color wrapper and gift wrap it again. So RGB, RGB, RGB. Cube, array matrix cube, array matrix cube, array matrix cube. That pattern keeps repeating infinitely. So you can have L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. That and the size of each packaging can change. Are you with me? Let's take a simpler example. Instead of taking n data points, let's take 10 data points. No n, no n, lm, no pqrst, no. Let all of them be 10. So I take 10 data points, I take 10 people in the flat, I take 10 flats, I take 10 states, 10 cities, 10 states, 10 countries. I just do groupings of 10. That's how I keep doing it. Do you know where I'm going? I'm going to the number system. Why I'm laughing is you will get it. So basically, let's take a number 456. Let's say I went to my backyard and there are stones there. I counted how many stones are there. I saw that there are 456 stones. Now this number 456, that is a data. That is not a tensor. I told you that is a simplest data structure is data, and so this 456 is basically the smallest building block, basically like an atom, right? No. Actually, that 456 is itself a tensor. That itself is a complex data structure. Let me unpack it. So take that 456. In that, the 6 is actually counting stones. There are 6 stones. But that 5 is not counting stones. It is a structure that is counting a group of 10 stones. So take 10 stones, form a group, and this 5 is saying there are 5 such groups. It is counting group of stones. It is not counting stones. Similarly, that 4 is not counting, is actually counting group of stones, and each grouping is a grouping of 10. The dimension is not element of PQ, it is all the same, it is 10. So 4 counts 10 groups of 10 groups of stones. I know that's complex. Basically, 4 is counting hundreds of stones. So 4 is saying 100 stones is a group, and I'm seeing 4 such groups. That is what that 4 is counting. So if I say 17345211196, then that 1 is counting a complex structures, and it is saying that there is one of such structures. I don't know if I made this more complex or more clear. But I just wanted to explain the beauty of tensors. So why I laughed previously was I started with me. I took a data points of my, uh, n data points about myself. I started grouping this way. And then I said grouping can be done in the opposite way also, meaning it's not just flat city states, galaxies. It is also cells, atoms, and quantum physics, right? Similarly, the same thing I'm explaining even in tensors. I started with a basic building block, a number, a data. Now I started combining datas into arrays and matrices and cubes. But then later I'm telling you that the data, that number is itself a tensor. That itself is a complicated structure, that it's counting structures of structures. Well, that is my attempt to explain tensors. I hope you liked it. I'll see you in the next one.